Imagine that you are standing before a road, a vast and endless landscape stretching out before you. The wheels of a vehicle slowly turn over the hot asphalt, but there is something there that you rarely pay attention to, something that is in direct contact with the ground, making the car glide smoothly or face the challenges of a rough terrain. This object is the tire, a seemingly simple invention that carries centuries of evolution, ingenuity, and adaptation. In the early days of humanity, there was no rubber, nor even the concept of tires. The first wheels, used by carts and wagons, were made of wood or metal, hard, unyielding materials that reflected the difficulty of transporting goods or people on uneven roads. However, what seemed like a limitation would later become the key to a revolution in transportation. For centuries, wooden and metal wheels continued to be the norm, until in the mid-19th century, a material that had been undervalued until then began to catch the attention of scientists and inventors: rubber. But what was so special about it? How could something so flexible and malleable replace the rigidity of the old iron wheels? The answer to this question began to be revealed during a period of great innovation. It was from this discovery that the covering of wheels began to take a form more similar to what we know today. But the transformation was just beginning. It wouldn't be long before tires became more than just a simple rubber covering. In its composition, we find a harmony between natural materials and chemically synthesized ones, whose combinations are perfect for ensuring the tire's performance and longevity. Rubber, both natural and synthetic, is the foundation that provides flexibility and grip on the ground, but its combination with other ingredients is what truly optimizes its qualities. Within this complex process, chemical additives play key roles. Among them, vulcanizing agents are essential for strengthening the rubber. Sulfur, for example, is responsible for vulcanization, a process that hardens and reinforces the rubber, making it more resistant to wear and abrasion. Without this step, the tire's durability would be much more limited. At the same time, plasticizers are added to provide flexibility. They maintain the rubber's malleability, which is crucial for the tire to withstand different temperature conditions without losing its qualities, preventing it from becoming rigid in cold climates or overly soft in high temperatures. But the story doesn't end there. To ensure the tire is even more durable and effective, antioxidants and antiozonants come into play, substances that protect the rubber from wear caused by exposure to oxygen and ozone. They help extend the tire's lifespan, preventing it from deteriorating quickly, a common problem when rubber is exposed to air for too long. However, it's not just rubber and its additives that make up a tire. Metallic components also play a crucial role. Steel wires, for example, are inserted into the tire's internal structure, providing essential rigidity and support. They help maintain the tire's shape and allow it to bear heavy loads, functioning similarly to reinforced concrete, which uses steel to strengthen its structure and ensure greater resistance. These wires, often invisible to the naked eye, are key to the tire's performance, giving it the strength needed to support the weight of a vehicle and the demands it imposes on the road. And if you think the complexity of tire construction is already impressive, know that we're just beginning to understand what happens inside one of the most important elements for vehicle safety and performance. Rubber and metal are only the base. Now, imagine the internal structure, where each layer and material has a precise function. The tire is not just a resilient rubber circle. It is designed to be a dynamic system with a combination of materials that work in harmony to ensure maximum efficiency. Inside the tire, there is the carcass, a fundamental layer that guarantees the shape and structural integrity. It is made up of nylon or polyester fabrics, resistant and flexible fibers that help distribute weight and impacts. These fabrics form a network that surrounds the rubber base and steel wires, functioning as a structure that distributes the internal pressure and stresses the tire faces with each rotation. The carcass also directly influences ride comfort, as it is responsible for absorbing much of the road irregularities, ensuring a smoother and more controlled driving experience. The rubber layer on the surface of the tire, known as the tread, is the part that comes into direct contact with the ground, and it is far from simple. Its composition is designed to provide the best possible grip, whether on dry, wet asphalt or even on more difficult terrain. To achieve this, the tread has a unique formula that combines special rubber with other materials, such as carbon and silicone, which enhance traction, improve durability, and help reduce fuel consumption, creating a perfect balance between strength and performance. Still, this complexity doesn't end with the structure. The internal pressure of the tire, which might seem simple, is another critical factor. It is precisely adjusted to ensure that the tire is always operating at its optimal capacity. The correct pressure is vital for safety, fuel efficiency, and even wear of the tire. And the key is balance. Too much pressure can make the tire stiff, leading to quicker wear and less grip. Too little pressure can cause the tire to deform, increasing the risk of failure and damaging performance. All of this, the rubber, metals, internal structure and pressure, works as a highly coordinated system where each component is designed to interact precisely. But when we observe how these parts connect and complement one another within the tire's engineering, there is an essential detail that is comparable to reinforced concrete, where the strength is enhanced with the addition of steel. In the case of the tire, steel wires are integrated into its structure to increase its strength and allow it to support even heavier loads. These wires form a true internal armor, reinforcing the tire's durability and integrity. And just like steel in concrete, the steel wires in the tire are essential for giving shape and rigidity to the structure, especially under high pressure and extreme stress. At the junction point between the tire and the wheel, we find the bead, which is usually also made of steel. This part is crucial for ensuring that the tire stays firmly attached to the rim, creating a secure seal. It is at the bead that the tire connects to the wheel, and its precise fit is critical for the vehicle's overall safety. If the bead is not properly secured, the risk of failure increases, which could lead to serious accidents. In addition to steel, some types of tires may also include synthetic fibers, such as Kevlar, which also play a key role. These fibers further reinforce the tire's structure, making it more resistant to punctures and cuts. Kevlar, for example, is widely recognized for its high strength and lightweight, making it especially useful in off-road vehicles that face challenging and unpredictable terrains. The incorporation of these synthetic fibers into the tire's design represents a significant advancement in damage protection and overall resistance. We cannot forget about the pigments, which play an equally important role but are often overlooked. They are added to the rubber compound, not only to give color to the tire, but also to protect the rubber from the harmful effects of UV light. Exposure to the sun can cause degradation of the material, weakening its properties over time. Therefore, pigments help extend the tire's lifespan, preserving its qualities for longer, especially under intense usage conditions. Finally, we have the tread, the most visible and crucial layer of the tire. It is made up of a specific blend of rubber and additives designed to provide the best possible grip on the ground. Its function is to make direct contact with the road surface, and its design, with grooves and carefully planned patterns, has a direct impact on traction, performance, and the vehicle's safety. The choice of materials and the design of the tread are vital, as they determine how the tire performs under different road conditions, whether dry, wet, or even on slippery terrains. The complexity of all these combined elements results in a product that goes far beyond a simple accessory for vehicles. The tire is a true masterpiece of engineering, where each component has a specific function designed to ensure not only performance but also safety and durability over time. But what happens when all these layers begin to interact with the real world, with the roads, impacts, and daily challenges? A question arises. How can all these different elements be in perfect balance, and what is the impact of this engineering on the driving experience? When the tire makes contact with the asphalt, its complexity begins to reveal itself. The layers of rubber, steel, synthetic fibers, additives, and even pigments work in perfect harmony to ensure the vehicle travels the road with safety, comfort, and efficiency. Each rotation of the tire is an example of resilience and adaptation, as it is constantly pressed, heated, and worn down. The tread, with its grooves and patterns, steps in to provide the necessary traction, molding itself to the terrain and ensuring the vehicle stays in control, whether on smooth asphalt or a wet road. The internal pressure of the tire, precisely adjusted, is what makes this interaction work optimally. It allows the rubber to deform slightly to maximize contact with the road, ensuring constant grip. The tread design, in turn, plays a crucial role. When you look at the pattern of grooves and channels, you're seeing the engineering behind efficient water drainage, or even the ability to dissipate heat generated by friction. On wet roads, for instance, these grooves help divert water from beneath the tire, reducing the risk of hydroplaning, something that could endanger the drive. However, the relationship between the tire and the road goes beyond simple physical contact. The internal structure of the tire, with its steel wires and reinforced layers, ensures that impacts from potholes, stones, or obstacles do not affect the integrity of the vehicle. These components act as a safety net, allowing the tire to withstand extreme pressures without compromising performance. Even when the terrain becomes rough, the flexibility of the rubber and the rigidity of the steel ensure that the tire continues to perform its role without fail. At the same time, wear resistance is another vital characteristic. Although tires are in constant contact with the ground and subject to friction, the combination of rubber and additives, such as antioxidants and antiozonants, helps preserve their qualities for longer. This means that even with daily use, the tire can maintain traction, grip, and safety, extending its lifespan and reducing the need for frequent replacements. But the performance of a tire is not something that happens in isolation. It is in constant dialogue with the vehicle and the driver. The behavior of the tire directly influences steering, braking, and even fuel consumption. Poorly inflated or worn tires can affect the car's performance, making driving more difficult and dangerous. Therefore, proper maintenance, correct alignment, and periodic pressure checks are essential to ensure that the tire continues to operate at its maximum potential. And as the tire faces these daily challenges, it begins to show signs of the hard work it performs. But how does it handle extreme conditions, such as high temperatures or off-road terrains? And what are the next steps for the evolution of one of the most important components of the vehicle? The answer to these questions goes beyond what we see at first glance. Despite its seemingly simple appearance, the tire is a true marvel of engineering, designed to provide traction, grip, and performance in a wide range of weather conditions and terrains. While many see the tire simply as a rubber wheel, the truth is that it carries a complex combination of materials and technology that ensure its strength and functionality. Its ability to bear heavy loads, withstand high internal pressure, and handle external punctures without compromising its integrity is what truly makes the tire essential for the safety and performance of any vehicle. The key to this impressive durability lies in the tire's construction process, which involves a series of precise layers and reinforcement with metallic components when necessary. Each layer serves a specific function and contributes to the tire's durability, flexibility, and resistance. The construction is not random, it is an art, a game of precision, where each material is strategically placed to withstand the demands of everyday use, extreme weather conditions, and the challenges posed by various surfaces. But after all, how do all these materials transform into a tire ready to be placed on a vehicle? The process begins with the preparation of the rubber compounds. In large mills, the rubber is mixed with the necessary additives until it reaches the ideal consistency. This mixture is crucial to ensure that the tire has the desired properties, such as flexibility, grip, and wear resistance. During this step, each ingredient is carefully measured to create the perfect combination that will be molded throughout the next stages of production. Simultaneously, the metallic components are prepared. Steel wires and bead wires, which play a vital role in the tire's structure, are cut to the exact dimensions needed. These metal elements provide the rigidity and strength of the tire, allowing it to withstand the extreme pressures of load and driving. They are precisely integrated into the tire's construction, reinforcing areas that require more strength and ensuring that the tire remains firm and functional, even in the most challenging situations. With all these materials ready, the time comes to assemble the tire structure, starting with the casing. The casing is the backbone of the tire, the base that will support all the other layers and components. This is where true engineering begins to take shape, as the casing needs to be strong enough to support the vehicle's weight and the forces generated during driving, while also maintaining flexibility to handle variations in the terrain. Now, what happens next in the construction process when all the layers begin to be joined? How does this combination of materials, rubber, metal, and fibers, transform into a fully functional tire, ready to face the streets, roads, and even the most extreme terrains? The tire construction process intensifies as each layer is carefully added to create the necessary complexity and strength. After the rubber is prepared, it is applied to a rotating drum, an essential component. To ensure the layers are applied evenly, the rubber is spread precisely over this drum, which facilitates the application and helps shape the tire's first fundamental layer. This is the starting point for creating a structure capable of withstanding the daily stresses the tire will endure throughout its lifespan. On top of this initial rubber layer, the cord layers begin to be added. These cords are made of materials such as nylon, Kevlar, or steel, which provide the tire with the necessary lateral rigidity. The tire's stability depends on these layers, as they help distribute pressure and impacts, keeping the tire firm and stable even under heavy loads. Kevlar, with its lightness and strength, is especially valuable in models that require higher performance and durability, such as off-road tires. These materials not only reinforce the structure, but also contribute to flexibility, allowing the tire to deform in a controlled manner depending on the driving conditions. After the addition of the cord layers, an additional reinforcement layer is placed, typically composed of steel wires or fiber. These wires are tasked with providing even more rigidity to the tire, strengthening its ability to withstand high internal pressures and increasing its resistance to wear. This step is crucial to ensure the tire has the structural integrity needed to endure intensive use and constant impact during driving. With the tire carcass almost ready, it's time to add the tread, the layer that directly contacts the ground. The tread is made from a specific rubber mixture designed to optimize traction, durability, and wear resistance. Its importance cannot be overstated, as it ensures the vehicle's grip on the road, whether on asphalt, dirt, or other types of terrain. The tread is molded with precise patterns and grooves, which not only enhance grip but also help with water drainage, preventing hydroplaning and maintaining vehicle stability. This is why there are different types of tread patterns, each designed for a specific road condition. Some are ideal for asphalt, others for off-road terrains, while some can be a mix of both or even adapted to ensure the best performance in more challenging conditions, such as snow or ice. Each pattern is a strategic choice that ensures the tire performs its function as efficiently as possible. After the entire internal structure and tread are built, it's time to bring everything together. The body of the tire begins to take its final shape as it's carefully rolled around a rotating drum. This drum, which has a flexible center, facilitates the joining of the edges of the layers, creating the basic structure of the tire. This assembly process is essential to ensure that all the layers are properly aligned and that the tire has the necessary strength and flexibility for its performance. But the construction of the tire doesn't end there. How can the next stage of the process further transform this layer assembly into a product capable of withstanding the pressures of the real world? What happens when the tire begins to receive its final treatment, and how is it prepared to face the challenges of the road? After the initial assembly and formation of the essential layers, the tire moves to the final stage of its construction, where it begins to acquire the definitive shape we recognize. Placed in a special mold, the tire receives the imprint of the tread with the desired patterns, which vary depending on the type of use and the function the tire is meant to serve. This mold is vital to ensure that all details, such as grooves and notches, are perfectly applied, ensuring the tire's grip and efficiency under different track conditions. The next stage is crucial and marks one of the most critical points in the tire manufacturing process: vulcanization. The assembled tire is subjected to an intense process of heat and pressure in a vulcanizing press. During this process, vulcanizing agents, such as sulfur, react with the rubber, creating crosslinks between the molecules. These bonds provide the tire with its essential properties of strength, durability, and elasticity, allowing it to deform in a controlled manner without losing integrity. Vulcanization transforms the rubber into a much stronger and more flexible material, ready to withstand daily wear and tear. This process takes 10 to 20 minutes, with temperatures ranging from 140 to 200 degrees Celsius, depending on the type of tire being produced. After vulcanization, the tire undergoes a rigorous inspection to ensure the quality and integrity of its structure. The first step is a visual inspection to detect any defects that may have arisen during manufacturing, such as bubbles, cracks, or irregularities in the rubber. However, the analysis doesn't stop at external appearance. Additional tests are conducted to evaluate the tire's uniformity, balance, and structural integrity, ensuring it is fully functional. Furthermore, specific tires may undergo performance testing, assessing their resistance to wear, grip, and traction on various terrains and under different weather conditions. Once the tire passes all these tests, it moves to the final finishing stage. Here it is marked with essential information, such as its dimensions, construction type, rim diameter, and load index. These details are crucial to ensuring the tire is used correctly, adhering to the recommended load and speed limits set by manufacturers. The speed rating is also indicated, helping guarantee that the tire is suitable for the type of vehicle and expected driving conditions. After this marking process, the tire is ready to be distributed to retail locations and ultimately mounted on vehicles to tackle a wide variety of roads. However, even after all these steps, what truly makes a tire stand out in daily use, whether on standard vehicles or in extreme conditions? How does it handle the challenges of the road, and what happens as it begins to age and wear out? These questions continue to highlight the complexity and significance of a tire, which goes beyond simple rubber and steel to become a critical component in vehicle safety and performance. Following the finishing and marking process, the tire undergoes a final inspection phase that includes a thorough cleaning. This step is essential to remove any material residue or impurities left behind during production, ensuring the tire is in perfect condition for use. Additionally, this cleaning process helps deliver the final polish, ensuring the product is free from any visual or functional defects and is fully ready for distribution. Now, regarding tire identification, an example of a specification might be a tire with a width of 265 mm and a height that is 65% of its width. The R indicates that its construction is radial, meaning the tire's chord layers are arranged radially relative to its center, providing greater flexibility and durability. The internal diameter, in this case 17 inches, is crucial to ensure the tire fits correctly on the vehicle's rim. The load index of 112 and the speed rating, indicated by the letter S, are also essential for determining the tire's capabilities, such as the maximum weight it can support and the highest safe speed it can achieve. These details help drivers choose the most suitable tire for their vehicle and specific needs. Each type of tire, however, has unique characteristics tailored to its purpose. For seasonal tires, specifications may vary to adapt to climate and road conditions. For instance, summer tires are designed for hot, dry climates. They use rubber compounds that remain flexible and grippy even at high temperatures, ensuring optimal performance on dry roads and some efficiency on wet surfaces. However, these tires are not ideal for temperatures below 7 degrees Celsius or for snowy or icy conditions, as they lack the deep grooves and aggressive tread patterns needed to ensure traction in such environments. On the other hand, when temperatures drop and the weather becomes harsher, winter tires are essential. These tires are built to handle extreme cold and adverse conditions like snow and ice. The rubber used in winter tires retains its flexibility, even at temperatures below 7 degrees Celsius, which is critical for maintaining grip and safety. Additionally, they feature a deeper and more complex tread pattern, designed to improve traction, particularly on slippery terrain. This allows for more effective braking and better vehicle control, even when roads are covered in snow or ice. His difference in design and functionality between summer and winter tires reflects the precision with which tires are manufactured and tailored to meet the specific needs of drivers and weather conditions. But what happens when the weather is more unpredictable? How do tires perform in situations that require a combination of characteristics from both types? When the weather becomes unpredictable, with mixed conditions alternating between low temperatures and sudden changes involving rain or snow, all-season tires emerge as a popular option. These tires are designed to provide balanced performance in a variety of conditions, both in warm and cold climates. Unlike summer tires, which are specialized for hot conditions, or winter tires, which are optimized for extreme cold and snow, all-season tires are made to perform well in moderate temperatures and on both dry and wet roads. The major advantage of all-season tires is their versatility. They are made with a more adaptable rubber compound, offering a good balance of flexibility and durability depending on the conditions. Additionally, the grooves and tread patterns of these tires are designed to provide decent traction on both dry asphalt and slightly slippery surfaces, such as those wet from rain or melting snow. However, as you might expect, this versatility also means that in extreme conditions like heavy snow or ice, they don't perform as well as winter tires. Therefore, if you live in regions that experience significant weather variations or prolonged periods of heavy snow, it's always advisable to use dedicated winter tires during the colder months. This balance between performance and adaptability is, in fact, a response to the growing demand for solutions that meet the needs of drivers facing unpredictable weather. However, for those seeking maximum performance in any climate, there are even more specialized tire types, such as off-road tires. These are designed to handle more challenging terrains, including dirt roads, mud or rocky paths, with deeper grooves and more aggressive tread patterns. These tires offer superior traction on uneven surfaces. However, like winter tires, they are not suitable for everyday use on asphalt. Now, what happens when tires begin to age and lose their grip properties? The natural wear of tires is a constant concern for drivers, as it directly impacts the safety and performance of the vehicle. How do tires respond to this deterioration over time? For instance, high-performance sports tires are specifically designed to maintain a firm grip, even during sharp turns and rapid maneuvers, delivering a precise and secure driving experience at high speeds. The tire's structure is optimized to ensure the vehicle maintains stability and control under these demanding conditions. Maintain their stability with minimal deformation under the high pressures caused by increased speed. The rubber compounds used in these tires are specifically engineered to withstand the heat generated at high speeds, ensuring consistent grip and performance. However, in exchange for their exceptional grip and stability, these tires tend to wear out more quickly when used under normal traffic conditions due to their softer rubber composition. While these high-performance tires are essential for vehicles reaching extreme speeds, tire wear becomes a more pressing concern when considering the life cycle of any type of tire. Over time, and with continuous use, all tires begin to wear down, losing their ability to grip the road effectively. When tires wear out, their performance drops significantly, which can be dangerous, especially in conditions like rain, snow, or ice, where grip is critical. Additionally, tires that have exceeded their wear limits are more prone to punctures or even blowouts, which dramatically increase the risk of accidents. Tire wear can be influenced by several factors, including improper pressure, misalignment, driving habits, and of course, the type of terrain on which they are used. Tires used on rough terrains, such as off-road tires, or even winter tires, may experience reduced durability if misused on paved roads. Conversely, summer tires, for instance, wear out faster when used in very low temperatures because their compounds are not designed to withstand extreme cold. Therefore, regular tire maintenance is essential to ensure they deliver optimal performance and, most importantly, to maintain the safety of the driver and passengers. In addition to checking pressure and alignment, monitoring the tread depth of the tire is a critical aspect. Shallow treads cannot efficiently channel water away, significantly increasing the risk of hydroplaning, especially on wet roads. How can drivers extend the lifespan of their tires and ensure they perform well for longer? To prolong tire life and maintain optimal performance, adopting a few simple but effective maintenance practices is crucial. One of the primary recommendations is to regularly monitor tire pressure. Improper tire pressure, whether too low or too high, can lead to uneven wear and compromise road grip, increasing the risk of accidents. Underinflated tires tend to wear more quickly on the outer edges, while overinflated tires may cause excessive wear at the center of the tread, reducing traction. Now let's talk about run-flat tires. These tires represent an innovation aimed at enhancing safety and convenience for drivers in emergency situations. The technology integrated into them allows a vehicle to continue being driven for a limited distance, typically between 80 and 100 km, depending on the brand and model, even after a puncture. This is made possible by additional reinforcements in the tire's sidewalls, constructed from durable materials that support the vehicle's weight even when air pressure drops or is completely lost. However, this advantage of continuing your journey comes with a trade-off. Run-flat tires tend to provide a stiffer ride due to their extra reinforcement, which can affect driving comfort. Additionally, these tires are often more expensive than conventional ones, and because of their specialized construction, maintenance, and replacement can be slightly more complex and costly. Now, you might be wondering, with so many options and innovations in the tire market, how do you choose the best one for your vehicle and driving needs? Well, selecting the ideal tire depends on several factors, such as the type of roads you frequently travel on, the climatic conditions of your region, and even your driving style. Sportier tires, such as high-performance ones, can be fantastic for those who love driving fast on dry roads, but are not suitable for those who face snowy or heavy rain conditions. On the other hand, winter tires are essential for maintaining safety and grip on icy roads, but they wear out quickly in hot climates, potentially leading to extra costs. Additionally, we have all-season tires, which are an excellent option for those who need versatility. They offer good performance in most weather and road conditions, making them a balanced choice for drivers who don't encounter extreme temperatures. For adventurers, off-road or all-terrain tires are ideal, as they provide excellent traction on challenging terrains, but can be somewhat noisy and less comfortable on paved roads. The key, therefore, lies in understanding the type of driving you do, the road conditions you face daily, and the specific requirements of your vehicle. By doing so, you can make the right choice and ensure not only comfort, but also optimal safety and performance. As you can see, tire technology is far from simple. Tires are true feats of engineering designed to maximize safety, durability, and performance. The question now is, are you ready to dive deeper into the world of tires and discover how they impact your driving experience?